Hello and welcome to OH3SPN Finland. Now, firstly, apologies for my sporadic content on YouTube. I'm trying to just record videos when I have something useful to say, normally that's come out of conversations on the various forums. I'm trying to concentrate on quality rather than quantity, so I hope that explains my randomness. Now, the topic of conversation today is filters, and this is a thing that keeps coming up, and again, I keep replying to people, I keep trying to explain things, and I think that's probably worthy of a video. So, filters, what they are, and how they operate, and what difference they make. The questions we see, or the comments I see repeated online are, I've just bought an expensive filter and I fitted it to my FT817, and it makes no difference. Or, it makes no difference, apart from it increases my noise floor. What's going on here? Or, a recent question, do I need to upgrade my filters for operation on the satellites? Now, I won't answer these here, I'll go into a bit of detail and then hopefully answer these later on or at the end of the video. So, first of all, we're talking about RF filters. That's filters that exist somewhere in the chain between the antenna and the receiver itself, or demodulator, however you want to look at it. We're not talking audio filters, although if we're talking, I can compare the two because most radios nowadays have both. Audio filters are like your tone controls that we used to have, or in some cases still have, on our hi-fi systems. You can just knock down the treble or take out some of the bass, or increase the bass, increase the treble. This is for really comfort of hearing. Or maybe you've lost a bit of your hearing due to age and you just need to increase the treble to increase the clarity. It is a comfort thing rather than something that can make or break a QSO. But yeah, the filters I'm talking about here are the RF filters, sometimes called roofing filters, or depending where they are in that chain, you may have just one, you might have several. In SDR receivers, you can have variable width filters. In the older radios, you'd have to have a selection of very expensive filters in the radio that you could then switch between. So, if we just take an example on the 40 meter band, I chose 40 meter because it's a busy band. Say we're transmitting on this frequency, or receiving more importantly, on this frequency, and we're on lower sideband. So our carrier would be here, but it's suppressed because it's sideband. Say our audio bandwidth is about 2.7 kilohertz for SSB, which is normal. Sometimes it's less, sometimes it's more. We won't get into the hi-fi audio extended SSB. But I mean, if this was AM or double sideband, we would have audio modulation across this section. But it's not. So we just have modulation appearing here on both TX and receive. This is all well and good. Say we've got an older radio, or we've got our modern radio with a wide filter enabled. I'm just going to draw some random lines in here. Say this is 2.7 kilohertz. I'll write KC because it's easier using a mouse. And our filter is, I don't know, let's say 3 kilohertz. So our filter is perhaps doing this, 3 kilohertz. That's all well and good, normally. But what happens if we have another station here? They're transmitting here, their suppressed carrier is there, and they've got modulation happening here. Well, this is when we get the squawky, tweety interference. We can still hear our station, but this starts squawking. You can hear it imposing on the pass band of the filter. And I mean, if this is a very strong signal, then it can really start to mask this, or just become uncomfortable to listen to. Yeah, depending on your radio, you may, if this is a strong signal, you might have some heavy AGC action, which will then drop your RF gain. So you can hear this signal, but this drops down into the noise floor. Again, I don't want to be complaining about certain radios that may or may not have this problem. But yeah, so what can we do here? Well, we can reduce our filter width. If we have a filter that cuts off here, then we'll lose a lot of this. Most filters, they're not brick wall filters in physical filters or SDR. They tail off, so you have your pass band like this, and you'll have something like this. So this is the band that we want. This is our pass band for the, say, 2.5 kcs, 2.7 kcs, but it never stops abruptly. Signals in these bits will still be heard. They'll just be attenuated, and the further away from the pass band you go, the heavier the attenuation. At this section, obviously, you're still getting some sort of noise passing through that filter. So the first comment people say, I fitted a filter, it makes no difference. Well, if you're on 20 meters and you've got gaps between each station, then you won't notice a difference. The other thing is, it's increased my noise floor. Well, on some radios and some filters, if you upgrade the filters, they can reduce loss. I think this is one of the things I experienced on the FT817. There's a horrible quality filter as standard, and it's reasonably lossy. And when you upgrade to the Collins filter, not only do you get much tighter filter, but you also get a few dBs gain, or maybe a couple of dBs gain, or something in that kind of figure. And with the 817 as well, it's not just the receive, but transmit audio as well is pushed through this filter. So if you reduce the losses in the filter, you also gain a bit more power. And talking about power, if you're using a filter on the transmit side that's 2.7 kilohertz wide, then your power is spread across that part of the band. If you use a filter which is 2.5 kilohertz wide, then you've got the same power going into a smaller section of the band. So theoretically, you could get a little bit of gain. Your audio will be less hi-fi, slightly more squashed, but your effective power may slightly increase. So now I will refer to the ICOM 7300 because they have a slightly different approach. And again, I don't want to start complaining here, but I can start ranting very, very easily, so apologies in advance if that happens. But the ICOM 7300, let's say we have our suppressed carrier here. We have our wanted modulation here. And we have our filters, say, here somewhere. Now, the ICOM 7300, you can adjust. You have a lower limit and a higher limit. But what you can then do is if you have a station interfering here, you can just lower this. You can bring it down to here just to try and cut out some of this. Likewise, you can do the same here. Or you can vary it down, you can pull it up. So you're basically, you have more flexibility over the upper limit and the lower limit of your filter. Now this is great in theory. In SDRs it's great. I mean, if you have like I'm using Quisk with the Hermes Lite. Yay, Hermes Lite, I keep saying how wonderful this is and how awesome the software is. But the filters really work very, very well. And if you have a signal here and you adjust your pass band so you're cutting it out, this really does go. You can cut it out dead. And I had the same experience with mechanical filters on the FT817 and FT847. It's very easy. I mean, you can't vary the width, but you can, inserting the filter, enabling the filter, you can cut out stuff that would otherwise be annoying. And of course, on these radios as well, rather than just enabling or disabling the filter, they normally have an IF shift. So what this does is you have your filter width here. The IF shift will move this whole filter like that. So it doesn't adjust the tone of the audio, but it effectively shifts the passband down. It affects the quality of the audio, but not the frequency of it. It's not like tuning away where the audio frequency will change. The frequency of the audio stays the same, but you can just cut off the annoying adjacent stations. Now, you can also do this on the 7300, but you have to adjust this passband and adjust this passband. So you're effectively shifting the whole of the intermediate frequency in traditional terms downwards or upwards, again to try and reject strong adjacent noise. And this is where I will start to complain. As I said on previous radios with mechanical filters, they're very, very effective. On the 7300, the filters sound effective. You can adjust the rate of which the side, I said about that filter, and it drops off like this. You can adjust whether this is a soft drop-off or more of a brick wall filter. It seems really quite nice indeed. The only problem is when you start to use it in practice. That's why I had the TS450S, the Yaesu FT817, the Yaesu FT847, the ICOM 706 Mark II-G. All of these radios, I upgraded the filters to Collins or Inrad, and all of them did a fantastic job at increasing the selectivity on just the part of the band I want, and rejecting noise on the sides. The ICOM 7300 if you have one and you've experienced proper filters, then you may share my pain. But I will say SDR in general should be much better at this. Whisk or Power SDR or any of the others, if you play around with these, you can see just how powerful SDR can be, at least when there's a bit of horsepower behind it on a modern PC. So, going back and answering the questions quickly, it makes no difference. Yes, it does make a difference. Try working SSB on a crowded band. Try working a contest on a crowded band. See how quickly you suffer from fatigue. It doesn't take long at all. I mean, if you're a CW operator, then it becomes even more important, even with practice. If you're using like an SSB filter that's 2.7 kilohertz wide, let's say, on CW, you can have 20 stations all within that passband, all sending CW at the same speed, at different speeds. It's just a wall of noise. And if you're a seasoned CW operator and you can work with those conditions, then huge respect to you. But me as a newbie, I need a filter. I need a good filter. So yes, it makes no difference if you're on an empty band. It makes no difference on 10 meters. It makes no difference on 20 meters unless it's crowded. So unless you test filters in the conditions that they're designed to operate in, then of course they don't show any difference. I think that's just a misunderstanding of what they do, and people expect them to sound different. Well, they only sound different if they're in a situation where they're rejecting something useful. It increases noise potentially, yes, I said. If upgrading your filters reduces your loss, then your noise may increase. The upside to that is get away from a domestic situation where you have a higher noise floor. Get into the middle of the countryside or somewhere far away from QRM. And that increase in noise translates to a higher... What is even the word? The dynamic... I want to say higher dynamic range, but that's not really what I mean. I just mean that signals that were previously down in the noise floor may now be lifted up a couple of dBs, enough to be workable. Finally, is it required for VHF, UHF and satellites? Probably not, but if you've got a station where you've highly optimized your receive signal path, then reducing losses again can make a difference. If you're investing in quality coax, you're investing in antenna preamps, high gain beams, dishes, then yes, if you can minimize losses and you have a radio that is affected by this, I don't think all are, in fairness, but if you can increase or decrease the loss, then yes, go for it. Generally on VHF and UHF, the bands are not that crowded, so it's not so important to have the filter for the pass band edges. Unless, again, maybe you're working a contest and 20 meters is cram-packed and you want to be working for 12 hours straight without giving yourself a migraine. So I hope that answers some questions. I hope it's been useful in some way. If you have anything you'd like me to cover, give me some ideas. I don't know what to cover unless I see something interesting discussed. There probably are topics that I can talk about that I'm just not really aware of, so yeah. Now, before I go, one thing I do want to ask, and I know I've said that SDR filters can be very good. I know they can also be good on desktop radios. A friend of mine had the Kenwood TS590 SG, I think. It was definitely the 590. Now, the DSP filters on that worked exactly as I would expect filters to work in a traditional Collins-type filter, only it had the flexibility of the DSP. So, I have an ICOM 7300. You may have been looking at my other videos, and you might be aware that for various reasons, it's a nice radio, but it's still, in some ways, quite disappointing. Can you recommend, without spending too much more money, a radio that has a DSP filter that works like a proper filter? I don't know whether upgrading to the ICOM 7610 is an option, or if I'll just hit more of the same kind of ICOM DSP filter issues. I've heard good things about the Yaesu FTDX10, which is obviously based on the FTDX 101. But I can't, where I'm living now, I can't easily get hands-on tests with these radios. There are no ham radio stores. And most of the reviews on YouTube don't cover these topics. It's like, yes, this is what it looks like. These are the buttons I can push. This is the menu. None of them really show the important features of the radio in real terms in day-to-day use. So if you have a radio, a modern SDR-based radio ideally, that has filters that work like filters, please let me know, as I'm still very much researching where to go from here. Thank you. This is OH3 SPN Finland, 73s.